Renaissance Charge Videos. I'm Rick Friedrich, and this is another video on the dual pole system, but it's on the loving path circuit idea. So what we have here is a motor energizer and then some. So we have many different kinds of outputs on this motor. I've shown this before, and I'm not going to show all the different things about it. I want to focus on the MICK coil, the MICK kit, we call it. As I said before, the RIC kit is this one, the Resonance Induction Coupler kit. We've talked about that many times. And that's the RIC kit, our coil, and this is the MICK motor induction coupler kit. And again, this is something I mentioned I think last video or the video before. So this is, I'm going to demonstrate it now. So what we have here again is a motor that's also an energizer. For those who aren't familiar with this, we've got a regular, well, not a regular motor, but if you think about a regular motor and then we're charging another battery at the same time, and so we have about equal charging to input to output. So this is the run battery, this is the charging battery, and we actually have the battery swapping system set up here. Every hour the batteries can rotate. So this is kind of a self-contained system here, and then we have generator coils. In this case we have 4 generator coils which have their outputs right here to this, through this variac. We're going to run to this 100 watt LED module here, and then from there we also have what I call EMP coils. Now this isn't the purpose of the video, I'm just going over some basics of this particular setup. And these create additional outputs, and I've got one of them hooked up here to an LED, 10 watt LED. And so again, these are just pulling out the extra energy like an EMP would give off. Electromagnetic pulse would give off energy which destroys a lot of your electronics, but in this case we're actually using that transmission to actually power loads. And it was interesting when I tried to look that up and find anybody who had tried to talk about that. There was really nothing I could find on the internet about such a thing. I thought that was quite interesting, the lack of discussion about that. So anyway, we have then a regular generator on the bottom here. It's actually rubbing against the pad here. This is an older setup where we have these coils that the rotors, sorry, are a little bit wobbly, so this is some vibration. And then, so anyway, we have a 50 to 100 watt generator on the bottom here, which I'm not hooking up, but it does pose quite a bit of a drag, whether it's running or not. There's a 3-phase motor, is what it, or generator is what it is, and so that's another output. So we demonstrate this. Well, I've demonstrated this before in a previous video, and we show this at the convention coming up next week. So it's not my purpose to get into all that. It's my purpose to focus on this. So what I have here is in series with the input battery, we have another inductor with a resonant capacitor, and so we have an induction coupling system here. And so what we're going to do is run that in series with the input from the primary battery. And of course I wouldn't really do this normally. I would put it here, the connection, but since it's all soldered up I don't really want to touch it. So the reason why I wouldn't put it normally on the outside here is because as it rotates in the next hour, after it's running for an hour, this will be the charging battery. We don't want this here. That would be more like the third stage process, which is not really what I would do exactly for that here, and I don't want to do that at this point. So this is just for the run battery, and so what we want to do is actually load it down. We want it loaded down, we don't want it unloaded, because the motor gets worse results when it's unloaded. So you got to think about Faraday's law and think about what's happening here. And so this is something that can be done. I'll show it after running the little window motor here in the same way. So this is going to be applied to all the monopoles and all the types of motors that we've made over the years. And so this is another major gain on the system. So what we've shown in the past now is how you can multiply the energy. So you've got the basic system where you've got one battery charging while another one's discharging, and you've got your motor power like normal. So you've got two outputs in that case for one input, more or less. Now if you want to add bigger battery banks on the charging side, and you have something like this gate driver, a very sharp pulse, very sharp square wave, if you will, then you can get more and more gain. So I've done up to like 250 times the output on the charging side when I had the big huge battery banks. I had to access them for 3 years. Big huge cell phone tower batteries that were like 300-400 pounds each, 2 volts. And I showed one of my earliest videos on YouTube here. You'll see an example of that where I have hundreds of times the output just with the basic circuit and bigger battery bank charging. So that's the impedance effect. Well, sorry, that's another whole story. I'm not going to get into that. But anyway, from there we've shown how you have a third battery bank. So you run the motor in series between 2 battery banks. So say you have 4 batteries running 2 in series for 24 volts and 2 in parallel, all equal batteries. And then you're connecting the negatives up. This is what we call a stage 2 process. And we run the motor between the 2 positives. And so there's 12 volts that would be running at the voltage potential difference between the battery banks. And so you're still charging up the 2 12-volt banks while the 24-volt is discharging through the motor. And then we have the third bank, 12-volt bank, charging at the rate that the 24-volt is discharging. So you got 2 sets of banks charging. So you have almost, in that case, with the right pulsing system, you can actually have 3 outputs for 1 input, roughly speaking. Again, the condition, the size of your batteries will affect that better and better as they get a bigger battery bank. So anyway, so that would be the second stage process, giving you 3 outputs for 1 input. Even the first stage, you can multiply again the output by the size of the battery, as I said, even hundreds of times more. So then we have what we call the third stage process, where we, like I said earlier, if we have this sort of kind of system on the back end going to the charging battery, we can multiply the energy out again and again through adding these resonant processes. So in this case, we're going to add a 4th type of output. Well, before we get to this, let's talk about, I've added the generator coils in such a way with this variac, as I've shown before, we can speed up the motor while we're running a load on the generator coils, and we still have plenty of torque left over. After we get past 20-25% on the variac here, or 20-25 volts, then it starts loading down those generator coils as a regular generator like this bottom one would be doing. And so it will slow down the motor at that point after that. And then, so that's all additive. Then like I said, we have the EMP coil um, position. Again, before I mentioned this sometimes, that these EMP coils are too close to the motor coils. We want them pulled out a little bit more than what I did. It was just convenient for me to do this before in this video, so I just left it. But you don't really want the wires touching each other. So then, of course, this is, we can call this a 4-stage process. Let's just do it. It just came to my mind right now. And so we're going to put this, I should have made this the 3rd stage, and then the 3rd stage becoming a later thing. But this is, we'll call this now the 4-stage MICK process, MICK kit, the 4th stage process. And so what I have again is in series, and this output is pretty much equal to the input. So I'll show this running later on at 400 milliamps, and then we'll have roughly about the same half a watt worth of light going on at the same time while we're still charging the charging battery. So in this case we're getting 3 outputs for 1 input. In this particular case we're getting more than that because I have some extra things going on here, as I just mentioned. But this is fairly significant, and the point is that this is not actually affecting anything from here on. It doesn't really notice it at all when it's loaded. That's a key point. When it's not loaded, it will affect things. When you think about an inductor, transformer, loaded and unloaded, there's a difference with this kind of system. So this is an air core, and this is part of what we'll do is include, I haven't decided on the price. I'll do that tonight and put it on the website. So I've got a whole box of these coils here. Another homeschooler is making these for me, and he's just anxious to make them up, so he made me a whole box of them. I'm ready to ship them. And then we've got these ferrite rods. So I will include some ferrite rod, 1 ferrite rod, and with a length of wire that you can wind yourself on there, and that will make it a kit. So you have to do something with a kit, right? And then you'll get one of these resonant capacitors. And then what I'll probably do is, well, you can add multiple ferrite rods in there and that. So it's going to be a affordable, really cheap kit that you can put together, and it's straightforward. It's plug and play. And you can apply that again to all the other circuits that, that do this sort of thing. So again, this is not the same as the 3rd stage process, because, so if this was the charging battery, you know, after an hour this would become the charging battery because it would rotate, because I've got the latching contactor here that rotates the batteries. And then what would happen if this was the 3rd stage process? This battery wouldn't charge as much, and there would be a lot of energy going back into the input. And that's not what we're doing here. It's a different, it shows you that the energy is not the same anyway. If you were to do this, you'll see what I'm talking about. It's a different kind of energy. It's the, well, I don't want to get into the technical side of it at this point. So anyway, like I said, this is kind of like an isolated body, as we talked about in the Resonance Induction Coupler Kit book. We talked about a multi-body, not out-of-body, not mystical things here, a multi-body as opposed to a single circuit that is a looped type of circuit where it's all contained together, all your grounds are connected together, and you know, full functioning circuit. This is a creates a multiple division, if you will. So if I had the diagrams here, which I do, me get these out here and explain a little bit, as I have shown these many times before. So we have the basic motor circuit with its flyback diode. So this is across the inductor motor is a single circuit here. Now this is kind of a multi-body thing, except the diode isn't really, I mean, it's still closed. It's not doing any extra work really in this arrangement. So what this creates is a multi-body situation. You've got still the loop here taking place, but now we've got an additional output. So this is the idea of the loving path. So this is a selfish circuit idea, which is consuming all the energy upon itself. It's discharging the battery, and then this one is opening up the door, if you will, sharing the load, sharing the energy, which is normally wasted here. Now it's charging this battery. Like I said, this battery, if it's bigger, it will charge out more. So now we're adding another, I don't have the diagram of this. I guess I got to make that now as part of the Loving Path series, that we're adding right here. I guess right where, normally we have the switch right here. Anyway, this was just drawn for convenience because you could do switching on either side. But this would be where the extra coil is. And so we're creating another body, if you will, outside there. So let's look at it from this perspective. So if this was the input battery, so if we had this all right over here, well, this is the second stage with the third battery bank, and this is the third stage here. So if we had this over here in the series here, then this is a second body. So we've got, in this case, we've got the first body is this in itself, and then we've got a second body here in this charging battery down here, and then we've got a third out here, a third loop, if you will. And you got to think of it as, while it's still connected in, it's in a different, it's got an independence of its own. And I'm not using the most technical words here, I'm trying to be real basic. But it's the ground connection, the negative terminal, which is right here, is, yeah, okay, so it's a little bit harder to explain this here. If we go to this one, it might be a little bit easier to understand. So you can see the negative terminals, while they're connected here, they're not connected here. So this is a separate system. This is sort of a separate system here, and then this is another separate system. So even though they're partially connected, it's still an other body, as we call it. So then, and this comes from the idea of the Tesla shuttle circuits idea, and I just call it a loving path idea because it's kind of using the energy, sharing the energy, if you will, using it effectively rather than just ignoring it like regular circuitry does. So again, if we have this over here as well, it would be totally separate, then these, then this system is by itself. It's just like radiation that goes away, like what we're doing with the EMP coils. We've got this pulse and we've got this magnetic output, which is being ignored, or normally, and now we're collecting it. So in this case, we're putting this inductor in series with the basic system, right? And this is another body, is what I'm talking about. So then we add we're not electrically connected at all with this ferrite rod and its coil, and we can of course collect the energy off of it and run our loads here. So let's get this all cleaned up so we can see what we're doing here. So we'll start off with this coil here. Rick's mess of wires. Alright, so now it's all ready to go. We just have to hook up the Arduino, and I suppose I could show this. There's no point, I don't need to show that right now. So what we're going to do, we'll turn this, let's just talk about this first. So this is, you could use this for the bigger motors, a big toroid, and you've got, your various options with your voltage and amperage output, input-output, with center tap toroids and that. So what I'm going to do is just show this running with the generator coils as well. This is kind of loud because I got that generator connected to it, and it's pretty junky bearings in it apparently. So let's turn on our meters here. Now, I'll show this in a minute. And I'll turn on this one. So this is the charging battery. I just ran it for a minute before I started the video. So it should be stabilized now. And then this one is the input battery. So 1281. So we'll look at the charging battery first. And what we can do is jumper a wire across. If I can find a wire somewhere. So I'll be jumpering a wire across the inductor to see the differences. So right now I'm just going to, let's see. See if I can put this up in a way that it can be seen. Try and zero it out. Alright, so now this green wire isn't anything special. For those who are wondering, this is, well, it is special, but not being used. This is to actually switch a relay for voltage monitoring of, say, if you're charging a battery, the generator coils, and you want to know what its voltage is, to switch it, to stop or start a relay. That's what it is, for those who are wondering. That's all those wires for. Alright, so we're going to run this now, and just get a feel for it. So we're at 1212 on that. So you can see there's a pulse there initially. Oops. So this is the generator coils. pretty bright. And so now this is the ferrite rod. It brings it down a bit. Then we can have a second one. And so that's the charging battery. It's the input battery. See, it's not affecting the amperage at all. I mean, it brings down the amperage, but not the voltage. So it's actually better when we load it. So there's only so much ferrite you can put in there. Blinding. Alright, so now we want to look at jumpering. So it draws more energy when I jumper the induction coil. You can see the amperage, the voltage is going down, and the voltage goes up. And if we go well, there's a voltage drop there right now. See, I'm loading down this now. This is really loading that down. Now the coils are shorted out. Anyway, I'm not sure if you could hear anything I was saying because this thing was so loud. So I don't want to just keep talking and not, make it so you can't hear me. So, and I've got to get the proper mic situation here hooked up. But again, I'm not really taking these videos too seriously. So, too bad. So anyway, what we have here is the amperage went down as I loaded this coil, which is important, and really it went down slightly, as we could see with the ammeter, and the voltage pretty much stayed the same on the input battery. And of course you can see a little bit of voltage drop across here, and I don't really have very good connections either with this. This is just a temporary fix here, but the point is you can get a whole lot more out. Now, we have to make these coils according to the right gauge. Right now I'm just using some 18 gauge wire, and this one has 23 gauge wire. This is more for the induction coupler, resonance induction coupler kits, which are running a lot less amperage. So, so these were running pretty bright because they can only put out so much power before you ruin them. So you can wrap thicker wire around here, around these ferrite rods. You can get bigger ferrite rods but these ones that we're selling are affordable for AM transmission, what they're used. So they're high frequency. And this is a higher frequency. I suppose I could have shown that on the scope, but we'll save that for another time. So anyway, it responds really well, and so there's some oscillations. Well, maybe I should run this. I haven't even done this yet, so we'll run it briefly here and see what's going on. If it doesn't work out, I can always cut it out with video. But you know I don't usually do that kind of thing. I show you the good and the bad, whatever happens. So we'll run it first without it, without the load, and then we'll add the loads and see what happens. Click. So what do we got on the input batteries? Come down a little bit. Let's look at the charging battery for a minute. $12.22, it's charged up. Like I said, it's kind of 1-to-1, depending on various factors. Alright, so you can see the damp wave. Right. I'll make sure it's in the video. So you got some oscillations going there, damp wave. So we got 66 volts peak to peak. Oh, we haven't even run. Forgot to put the loads in. right, so this thing's an animal. Alright, so I stopped it here for a second, frozen it. And so now we can look at this. So that's unloaded, but loaded, you can see it's dampened more. So this is kind of like the not tuning anything. So you've got, this is like ringing the bell, the hammer bell idea. So you can see the ringing of the bell is taking place at this point, and then it's just dampening down. It's nothing major, but it is enough. You know, we've got 64 volts peak to peak, so I could probably actually run one of these 100-watt modules in there instead. These ones are great. They have their own rectification in there. They can run either as AC or DC, so they're great little spotlights. So anyway, yeah, you've got your damped wave there, and you've got another one, as you can see there, a little one. So let's expand that out a little bit. You can see the other one is 13 volts peak to peak on that smaller one. And there you have it. So there's your extra energy again, one more time. There's a lot of things that we can do, as I've said all along, and now, you know, demonstrating them all for you to see. Easy to do, and this is just one of the ways to pull the energy off and use it. And you know, this one doesn't require any frequency adjustment. So the divisions here are two milliseconds divisions here between peak pulses there. So we've got some frequency going on there, not really high or anything, but between the oscillations we've got some frequency. The ringing of the bell. So 20 microsecond divisions there. So everything's got its natural frequency. You've got inductance and capacitance, and when you ring the bell, this is what it's going to resonate to. So we're going to be talking about that next week at the Renaissance Convention here in Lansing. And I'm going to show, focus is going to be on waves predominantly, and the Don Smith book, of course, which has shipped now. Almost all the orders have shipped out. We're still waiting on some of the parts for some of the resonant coils, because everybody ordered it like crazy the last 2 months, and we're trying to keep up with all that. Thank you for your orders anyway. So we're talking about waves, and we're talking about resonance here. So we have a little bit of resonance going on here, and with each oscillation here, we're getting a repeat of energy, which we're outputting. This is sending a magnetic impulse out, and we can still get some on the outside too, but the ferrite inside generally pulls in the fields internally, and we can utilize that energy that, again, nobody would be doing. So this is kind of like a reverse of the heavy side current, like we talked about before. So on the charging battery, well, really on all the wires, when you pulse energy through a wire, anyway, actually not even pulsing, just if energy is passing through a wire, then actually the main, let's see, we're only collecting the, just a little, we're kind of skimming off the main current going through parallel to the wire, right? We're only collecting a little bit on the surface of the wire, and then that's what people think all the energy really consists of, is what you practically use in the wire. But as I've shown, if we go at right angles to that and we put sails and we consider that wind, we can collect that, which is what I've shown before, and that's what we're doing in the batteries. If you think of the charging battery here, the energy is passing from one side through, and then the plates are at right angles, they're collecting that energy. So in the same way, this is kind of passing through this inductor, and if you consider this like a sail, it's not really the same idea, but I'm just trying to give a simple analogy how we're collecting more energy. In this case, we're creating, like I said before, a multi-body where we are we're creating a capacitor and an inductor in parallel with each other, and so we have a circulating current there that is separate from what's happening in the motor. So it's like, this is a filter type of thing, but in this case we're actually using it to do work. So the circulating current here is multiplied, and then people look at this as a filter and don't run any loads off of it, and that's where they leave it in their minds, thinking, okay, well, great, it's just a filter blocking out particular frequencies or what have you, purposes, dampening voltage, transient spikes, whatever. But in this case, we're running real loads off of it, and we're not affecting the motor operation or the charging effect that we normally do. So this is like a multi-body situation here, especially with this. This is certainly not even electrically connected, so that's independent altogether. But the flow of energy between the two parts is creating an oscillation, as we can see, and that's really, you need to think about that as separate from a regular circuit flow. Like we had with the loop. So this is, like I said, is really separate from this. And so you've got to think of it that way, in this way as well. We've got a capacitor and an inductor, and you got to think of it like it's a separate body. And that's where the more we multiply bodies, if you will, this is like Tesla's shuttle circuits, and we can get gains independent of each other and multiply the energy out in various ways. Because every time you spin an electron, you get both magnetic and electric output. So you get two outputs for one input. And so if you, whatever it takes to spin electrons is energy pump. And that's what we're doing with the Don Smith systems. I wanted to show all this kind of thing. It's still applicable to the motor, and it's easier to do with the motor. So that's why I've stuck with the motor, and I think with most people that's what they're after, is something that's easy, plug and play. They don't have to learn all the technical things about resonance. When we're making resonant systems, we generally have to be very precise and our wire lengths and all those details to get it very precise. So it's not for everyone to do that, but the motor systems are plug and play. Like you can see, okay, I've got this damped wave, but we've got how many oscillations here? You know, significant. So we've got 1, 2, 3, 4, 5, 6, 7, 8. You know, 8 oscillations from 30 or 30 volts peak to start, and then it goes down from there. And again, you can tune this with multiple capacitors and do different coil arrangements and stuff like that. And the good part is, as you want to run the motor harder, like if I ran the generator coils and was really loading it down, like I was only running this thing at 3, 4 amps, and so if we wanted to go up to the 8, 10 amps kind of maximum that this will go to without getting it too hot in the coils, this will produce more and more as well. So this just in the charging battery will charge up more and more. The EMP coils will put out more, so it just goes up and up. So it's all balanced together. So we'll do this kit first for the motor coils and all the previous mini kits, the fan kit, the window motor kit, which we can run now. I can do that real quick, like I said I was going to do. So let's just look at the batteries. See where they're at. Oh. So this is at 1276. It'll come back up as it rests a little bit. I mean, it has discharged a little bit, but it will probably come back. 1221, 20, 21, 22. So that's gone up, and this has gone down pretty much at the same rate. And we'll just move this thing out of the way. We're done with it. And then we will look at the window motor for a moment. Like I said we would. And we'll add here. This thing goes pretty fast. Need another battery. So what we'll do, we'll run this. See what the voltage, which one should be the charging battery and which one the run battery. 1247, 1247, so they're pretty much equal. So this one, we'll just make this the input. Oh wait, I gotta move this in a way that can be seen. And I'll need a red wire. No. Use a red wire. We'll hook up our charging battery first. Otherwise, blow out the circuit. Right, so I'll leave this now. So we're going to run this one, and you'll see it's pretty much the same, because these bulbs are more for the lower input. Well, they can do the higher input too. But so we're going to run it first, bypassing the coil. And let's look at the charging effect. Now this is not as stable as a motor. So you can see 12, 51, 52. And this one will kick into gear. Alright, so let's look at the amperage. .31 milliamps. Now it's going to kick into gear when I what I did is I now am not bypassing. So notice I actually loaded it down and it's speeding up. Interesting. Alright, so there's the one coil. Now you can see the two don't really want to go together. So we'll just remove this one. And let me get this thing tuned up here. There we go. I was waiting for it to get that little lift there. So 1255 is the charging side. It's really unaffected by the charging is unaffected by this process. So this is again the more negative circuit. So 1256 still 1256, didn't change. And then the amperage of 444 or 440 milliamps. Or here 450. It's really unaffected. So then the input voltage so 1225, 1226. Okay, so that shorted it down, but it's gone up to its next point now. So that shorts it out. It's the same voltage. So this is a very finicky system because the coil position can dramatically change the system. So it's a fun thing to tune and play around with, but it's not as stable as all the other motors, unless you stabilize the coil, right? So you can see it's not really affecting the circuit. That's my whole point here. If I could remove these wires. So we can look at the scope again across the collector and emitter. If I can get a hold of that emitter there. Alright, so let's go back and look at, oh yeah, I'm not looking, that's where I usually look. That's not where I wanted though. I wanted across the coil. Now, this is not even showing you the ground connection. I haven't shown that yet with the motors. That's coming. So let's look at that again. We got the same thing. We got more action here. Oh, yeah, we've got, look at that. There's some nice oscillations. Okay, so that's without, you can see the dampening effect. But we still got some significant oscillations. We've got 32, up to 34 volts, peak to peak. And they're a lot more frequent. So, we've got a half a watt, roughly half a watt. No, sorry. We've got about 5 watts, 6 watts of power, and then we've got some action here. So, anyway. It's something that you can play around with, and let's try the other one actually. This one's got a smaller coil. This one's got a center tap for us to do the ground experiments with. So that's going to be a higher voltage. So yeah, this is not really the coil for this small of a motor. This is more for the bigger coil system. It's thicker wire than that. So let's disconnect it. Let's look at our voltages. We already looked at this. That's the input side. That's going to come back up. That's the charging side 1257. Now these aren't, normally we have a negatively charged battery on that end when we run these, because this is a negative output. We don't have the capacitor pulsar on it. Anyway, so this is just another form of energy that really doesn't affect the motor operation, and depending how the wire size, the load that you're putting on it inductively will give you interesting results. So this is just the first demonstration of this idea, and then we'll do maybe next week, at least at the convention, I'll be showing a big 4-pole, 4-dupole motor with a bigger load, bigger coil set, transformer probably in that case, with the that toroid there, or another one I'll be using, depending on if I have time to do it. May not. It may just be for the attendees of the meeting, which I think I only have one seat left for the meeting. It's really sold out. Anyway, so that's just one other thing that can be done. So thanks for watching.